Hey everybody, here we are at the University Farm, week 2 or 3, however you want to look at it. So this week we would have been out looking at this amazing soil pit that just got dug. Shout out to our farm staff, Mike Jones and Matt Housley, for getting this thing dug out. Whenever you get a chance, if you got a big backhoe pit and a big soil pile, jump up on it, get a lay of the land, right? We're going to be talking about landscapes and why things are where they are. Anytime you can get a nice view and see what's going on, that's always great. What we're going to do today is we're going to expose you to a soil pit and talk about, and you're going to get to see the process of cleaning the soil pit face up. And we'll start really on the first step of Horizonation and thinking about why things are similar or things are different in the profile. That's going to be a big goal today, is that split. Whenever you're looking at a soil, you're looking for things that are similar and you're looking for things that are different, and you're always looking for that why, right? You're trying to figure out why are they similar or why are they different. If enough things are different, then that's when you're going to start making decisions about horizons based on a bunch of different diagnostic features. The texture, the structure, the consistency, roots, pores, color. There's a lot of different things at play, but ultimately by the end, you'll get in the pit and start making calls and making decisions, and then being able to have the fun conversation about why you think that's true. So I'm going to head down, I'm going to drop in, as they say, and then we're going to get to this soil pit. So here we are now down in this really nice road cut, or a backhoe pit, right? We started up, I was on the pile. That was all the material that got dug away from this piece of the landscape to expose this nice vertical pit so we can look at the properties and different features. We're outside, Irv's more than 6 feet away, so I'm going mask free, but shout out to staying safe and sane, right?
And I'm wearing a mask.
And Irv's wearing a mask. Our goal for the whole semester was to stay safe. We're not going to be doing it together every Wednesday or Thursday, but still, let's bend the curve and flatten the curve and all that stuff. So today in lecture, or in lab actually, one of the students asked me, do I need a bunch of tools if we're going to be doing things on our own and trying to experience soils without being in a lab setting? I'm going to tell you that really all you need is a couple of things, and that's one of the things we're going to stress this semester, is that you don't need a lot of fancy tools to characterize and understand soils. You need a knife, a pit face, probably a tape measure, maybe some flagging, and a couple other small tools. But really the key thing here is your senses, your sense of sight, your sense of touch, smell, taste, hearing. They all can be employed when you're thinking about soils and you're trying to characterize a pit. So what we're going to do now is, this pit's got a bunch of smears and pieces of spots where there was the backhoe tines were coming in. And what I'm going to do right now is just take a moment and clean up a surface of this pit so we can start talking about horizons and roots and all those other features. I'm actually going to double use my mask. Sometimes picking soil pits can be pretty dusty, so I'm going to go under the cover and try to protect my lungs, not from the Rona, but from these fine colloidal particles that might be flying around in the air.
Silicosis.
Silicosis. So when you're picking a pit like this, you're not just getting the soil material out of the way. You're actually kind of doing a pre-assessment. You're thinking about how easy stuff pops out, how big are the features that pop out. You can see here that sometimes you're seeing these aggregates fall out. Here we go. Here's a soil that's been aggregated. We talked about secondary structure in one of the early videos, and here it is, right? The particles, sand, silt, and clay, coming together to form secondary aggregates, or PEDs. And like I said, you can start to understand how big things are, how soft. The difference in consistency from right there to right there is very considerable. This is soft and unaggregated. This has nice big chunks that fall out, right? No idea why right now, but those are the kind of things you're looking for as you're cleaning up the pit, right? You're seeing what happens, you're seeing what pops out, and you're kind of getting down with the soil, right? You're just giving yourself a chance to feel it, touch it, understand what it looks like, and not really judging, right? It's equal opportunity for soils. Don't come into the pit thinking you know what it is. Let the soil talk to you. You'll have a better idea. You're not just going to show up and start digging a hole and characterizing it, especially for a job or something. But what you really want to do is let the soil talk to you. Let it tell you what's going on. Let it show you what's going on by how it expresses itself when you're popping out features like these aggregates right here. So I didn't bring a bunch of different stuff. I brought a lot of similar things. Sometimes I do that. I'll joke that really soils and a lot of things in natural resources is, can you get it done with what's in the back of your truck? Can you get it done with what's there? And like I said, throughout this semester, I really hope one of the goals is that you realize that you don't need a lot of fancy tools. Here we have some big metal stakes, some chopsticks, got a rock hammer, pizza knife for cutting dough, which is a great tool for certain things. Got some water for washing your hands or wetting up samples. A couple of different root cutters if you got to cut roots. And that's about it right now. Usually it would have a couple other things. Color book, the purple book that you use to do all the field characterization. We'll talk about that a little bit. And a few other things. Often too, sample bags, a field sheet, some of that stuff. And really throughout the semester, we're going to come back to this site a couple times, and each time we'll expand and we'll start bringing those other pieces back into the story so we can start to give you a full picture of what's going on here. There'll be other stuff that won't be about soil characterization, obviously, water holding, organic matter, and other things we're going to work on too. So I think we're at a good spot. We're going to start trying to horizonate this pit, and then we'll be ready to roll from there. Look at that, dude. That's some fresh rocks. That's awesome. Good gravels. Okay, so where to start? Soils form from the top down and the bottom up through that integration of those spheres that we talked about: hydrosphere, geosphere, biosphere, and atmosphere. Also, there's weathering processes, the flux of material down into the profile. So much to talk about, and like I said, we'll build on that throughout the semester. Most organic rich horizon, most activity, most energy flux is occurring in the surface. That's where all the fine roots are. That's where the water's flowing in from above. In the middle of the profile usually is a place of accumulation, right? We'll talk about E and I alluviation. One is E is the process of leaching, and I alluviation is the accumulation of material. And that's a common process in soils where fine particles start to accumulate in the subsoil. That's what we would call a B horizon by our taxonomy. And that's where texture will change. And aggregation will start to really express itself nicely through the size, the angularity, and the consistency of the aggregates as they're coming out of the pit. At a certain point, the leaching and the weathering, depending on the climate, is very different in tropical environments and subhumid places versus our Mediterranean climate. Then we start to get stuff that looks similar to its original parent material. Less weathering, less accumulation, less organic matter, because the processes that are really strong and occurring up here aren't making it all the way down into the profile. Okay? If we wanted to use the terms, we could talk about A horizons, B horizons, and C horizons. So before we get to the details of which and where, we'll talk about the general nomenclature of horizons. We always talk about the A horizon being the surface horizon. As I said a moment ago, that would be the most organic rich, the most roots, often a fine granular structure because of the nature of the environment. Then you start getting into B horizons, right? Now, before I move on too quickly, an interesting feature about our soils here at the University Farm is they're mapped as PACIC. The designation inside the taxonomy is trying to tell you that they would have very thick, organic rich A horizons that might extend down well into the profile, up to 3 feet. We'll figure this one out as we go forward, but you can see that all the way down into here, it looks a little looser. It's definitely darker than above, and this might be a really good example of that thick A horizon. Or you could have multiple A horizons, so not to get too far in digression. Then we get into these B horizon materials, right? Stuff that's aggregated. If you texture it by hand or through other methods, you can start to feel a fining or a less sand sand as a contribution or more clay as a contribution. And that's kind of characteristics of these mid-profile subsoils. Then we get down into the sea horizon material, which is the stuff that looks a lot like what it would have looked like when it was deposited. Remember, this is an alluvial environment. We'll talk again about Butte Creek and how Butte Creek used to come on, part of Butte Creek used to come onto the farm. Another thing you could always think about to know it's an alluvial soil, especially if you have an amazing exposure like this, are the rounded nature of the rocks, right? These rounded cobbles tell you that this soil was deposited by water, or this material was deposited by water. Rocks don't round like this unless they're tumbled and tumbled and tumbled down a watershed, chipping off all the edges and rounding them off. This is a really great example, or I'm really excited to see this pit. I didn't see when they were digging it, to see all this bed of gravel that's down here at depth. This tells you very clearly that this pit used to be the stream channel. This would have been Terrace 1 that we talked about in the first video, in that, tread 1 in that tread and riser. This would have been where the water was flowing over. When the channel network changed for whatever reason, and that's the nature of alluvial floodplains, finer materials started to pile up to get up to this about 5 feet of finer textured material. We're not going to get into it too much today. I want to tell you the whole story. So excited. But we're going to keep it a little bit closer today because we're going to come back to this pit a couple times in videos throughout the semester to talk about a variety of different things that are interesting about soils. Okay, here we are. I'm gonna horizonate this soil now. Like I said, horizonation is part art, part science, using all your senses and trying to decide where things are similar and where things are different. And what I'm going to use is I'm going to pick through this pit. I have a pretty good idea where I want it to go. And I'm going to mark each horizon boundary with some white flagging so you can really see where it is. For this one, actually, I'm going to move over to go back to something a little bit heavier. It really depends. Like sometimes you can use these flaggings. Sometimes the soil's too consistent and it doesn't want you to stick a stick in there. I'm going to see if I can use these chopsticks now. See how they fit. They stick in there pretty good, so you can really see what's going on. Haha, some doesn't want to really get in there. It's so densified right there. It doesn't really want to go, but we'll make it work. and then below that. So we have a variety of horizons here. Your surface horizons that are darker and a little less granular, a transitional horizon, some structure, and then getting down into these sandier things and these rocks. I left it really simple and really basic right now because I don't want to try to overwhelm you with too many ideas. We're going to end this here right now, but we're going to return to this pit multiple times this semester and show you about all the basic fundamental properties of soils through this one individual pit. Okay? Take it easy. I'm looking forward to watching this video with you all in lab next week and to see what you think. Have a great day. Stay safe. Enjoy Labor Day weekend, and see you till next time.